The safe and durable installation of car windows requires maximum precision in the pre-treatment process. Before the glass is bonded, the edge of the window is coated with a special polyurethane coating. This ensures a secure and durable connection to the vehicle frame. In order to fully automate this process and collect important measurement data, the machine manufacturer BBG from Mindelheim in Germany has developed a scientific test facility. The entire system relies on machine vision products from wenglor. The windows are placed in a rotating rack and loaded outside the enclosed system. A robot then removes a window from the interior and begins the finishing process. Two B50 vision sensors from wenglor are used for high-precision alignment and pre-treatment control. The first sensor assists the robot in precisely centering the glass disc. The second sensor uses an UV ring light to monitor the seamless application of the coating, which serves as an adhesive between the glass and polyurethane. We were able to integrate the B50 vision sensor ourselves easily via the Profinet Ethernet interface. In addition, data evaluation and operation were possible in parallel, which was very important to us. Another key feature was the tabular calculation function in an Excel-like structure in the uniVision 3 software. After applying the coating, the robot places the glass disc in the curing tower, where the primer dries under controlled conditions. At the same time, another robot cleans the tool in a mold carrier, preparing it for recasting the component. To overcome the challenges of reflective light and surface conditions, the B60 smart camera used is equipped with an additional infrared light from wenglor. The B60 smart camera mounted on the cobot checks whether the mold has been completely cleaned. It is crucial that the tool is 100% clean, and thanks to its high resolution, the B60 identifies even the smallest particles, thus ensuring a stable quality assurance process. The captured images are forwarded to the higher-level control system via the integrated Ethernet interface and then evaluated using AI. Once the cleaning process is complete, a robot retrieves the finished glass disc from the tower and places it in the mold carrier. There, it is encased in polyurethane. The robot then removes the finished component and takes it to the trimming station, where excess burrs and polyurethane residues are precisely removed. Finally, an MLWL 2D/3D profile sensor from wenglor checks whether even the smallest material residues remain on the component. If corrections are necessary, the component is trimmed again until a burr-free result is achieved. The combination of BBG's system expertise and wenglor's machine vision products enables the production of high-quality finished glass discs. At the same time, the entire manufacturing process, from glass supply to the finished component, is monitored reliably and transparently.